Good morning, students. Hello, everyone. So, in the chapter 10, that is light reflection and refraction, here I'm going to discuss some of the questions of page number 176. And page number 176, there are 5 questions. So, out of those 5 questions, I am going to start with the first question. The first question says that a ray of light rolling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? So this is the question. So we need to justify the question whether it will bend towards the normal or it will go away from the normal. So we have to justify the question. So here I have drawn this diagram. So here you can see one blue line is there. This blue line is obliquely entering into the second medium. So one black line is there. So below the black line that is considered as water, and above the black line we have this air. So here we will consider that above the black line it will be air, and below the black line it will be water. So this will be the surface of the water, the black line, and the red line is here I have marked. It is considered as the normal air. So the blue line, which is coming slantingly or obliquely, it is entering into the water. So once it hits the surface, it will refract. As we know that anything that comes from rarer medium and if enters into the denser medium, the light ray changes its path. So that was the definition of refraction. So you need to remember one thing, that if a light ray comes from a rarer medium to denser medium, the light ray always bends towards the normal. And if the light ray goes from the denser medium towards the rarer medium, then the light ray will travel away from the normal. So here you can see the blue line. If we consider this blue line as the origin, then at the point of incidence, after that one the light ray is moving from away from the normal. Because here if you consider it is going from rarer medium, denser medium to rarer, then it will be away from the normal, and if it moves from lighter to denser, it will always come towards the normal. So here the question was like air enters obliquely into water. The light ray is traveling from air into the water, so that's why it is towards the normal. Okay. So the next question says that light enters from air to the glass having refractive index 1.50. What is the speed of light in the glass? The speed of light in vacuum is 3 into 10 to the power 8 meter per second. So refractive index is given 1.50 for glass in respect to air. And what is the speed of light in glass? We need to find out. Okay. So the speed of light in vacuum is also given, that is 3 into 10 to the power 8 meter per second. So you know what is vacuum, that already you have learned in class 9. So the refractive index here we have to consider it as a absolute refractive index because it is in respect to vacuum or air. So what are the things given? First we need to know. So the given things are like refractive index of glass, that is n is equal to 1.50, and what are the things given? Then a speed of light in vacuum is given, which is symbolized with c, that is 3 into 10 to the power 8 meter per second, and speed of glass we need to find out. Speed of light in glass. So speed of light in glass, that is v, we need to find out, and we know that there is a formula, that is refractive index is equal to speed of light in vacuum divided by speed of light in the medium. So here I have written the shortcut or the symbolical formula, that is n is equal to c by v. So the values are given as n is equal to that is 1.50 is equal to 3 into 10 to the power 8 by v. So after this crossing we find that v is equal to 3 into 10 to the power 8 by 1.50. After cancelling we find that v is equal to 2 into 10 to the power 8. So which is the refractive, that is the speed of light in the glass. So therefore the speed of light in glass is 2 into 10 to the power 8 meter per second. Okay. So next we will move to the third question. Okay, one second. So here is the third question, that is find out from the table. There is a table in your textbook in the page number 175, that is table number 10.3. So here are some materials are given, some materials are given, and some refractive index also given. So from that one we need to find out which medium or which material have highest optical density and which one have the lowest optical density. So here I missed one thing, that is table 10.3. so here I am reading. So from this table 10.3 that is present in page number 195, we need to find out which medium have highest optical density and which medium have lowest optical density. We need to find out. So here different materials are given like air, ice, water, alcohol, kerosene, then fused quartz, turpentine oil, benzene, chrome glass, Canada balsam, rock, salt, carbon disulfide, dense, flint glass, ruby, sapphire, diamond. So different materials are given, and if a refractive index of those materials are also given along with the names. Okay. So here we need to find out which one has the highest optical density. As in the previous video also I have told that the more the refractive index, the more the dense the object is. So here you can see air, which is very light in optical density. So here air will be the lowest with the lowest optical density, and in the end we have this diamond, which has a refractive index of 2.42. So at the end you will find it in your table. So the refractive index of the diamond is 2.42. So that will be the highest optical density. That material or that medium will have the highest optical density because the refractive index is more. So if the refractive index is more, the optical density will be more, and if refractive index is less, the optical density will also be less. So here air is 1.003, that is equal to roughly equal to 1, and that is in compared to the diamond, which is 2.42, which is highest in this table. So that's why the highest optical density will be for diamond and the lowest one will be for air. Okay. So and the different other materials are there like ice, water, and so they have a different refractive index. How do you find out this refractive index? By finding out the that is dividing the speed of light in vacuum in the with that light in speed of light in that medium. Okay, so the fourth question is this: you are given kerosene, turpentine, and water. So three liquids are given. So in which of these does the light travel first? And another question is also there, that in which of these liquid the light travels slowest? So these are the three liquids: kerosene, turpentine oil, and water. So out of these, in which one does the light travel fastest, and in which one does the light travel slowest? So use the information given in table, that is 10.3. So from the table we will find out the answer. So in that one we have this water, that is 1.33, and kerosene 1.44, and turpentine oil is 1.47. So if the refractive index is more, the substance is dense, we know that, and if the dense substance is dense, then the light will travel slow. We need to remember that. So turpentine oil has 1.47. So out of these three, this turpentine oil on the light will travel slowest, and in water, that is 1.33. Among these three, in water the refractive index less, means the water has less density in compared to those other kerosene and turpentine oil. So in water the light will travel fast, and in turpentine oil it will move slowest. Okay. So the fifth question is this: refractive index of diamond is 2.42. Then what is the meaning of this statement? Okay. So the question says that refractive index of diamond is 2.42. So refractive index of diamond, here we have to consider it as absolute refractive index because it is in respect to air or vacuum. So the refractive index or absolute refractive index, that is Nm, is equal to speed of light in vacuum by speed of light in the medium, that is equal to C by V. So this is the statement, the meaning of the statement is that when we divide the speed of light in vacuum to that speed of light in the diamond, then the ratio of these two comes 2.42. So when we divide the speed of light in vacuum by the speed of light in the diamond, and we find out the ratio of 2.42, which is the refractive, which is nothing but the refractive index of diamond, which is 2.42. So this is the meaning of the statement. So I hope up to this much is clear, and from now on I will be trying to make such videos, and I will try to explain all the questions. These are not your notes actually, these are just the explanation, deep explanation of these questions given in your book. I will try to solve all these questions. So this type of videos will help you definitely, and you will be benefited a lot. And thank you for watching the video with so much of patience.